Okay, we left off on lactose. So where do you find it? Milk. That's the sugar that's found in milk. And how is it different from sucrose? If you look over here, it's this bond right here that's different. There's sucrose, table sugar, and there's lactose. It has a beta bond, and this one has an alpha bond. Does it matter? Well, it matters a whole bunch if you're lactose intolerant. Turns out, if you're lactose intolerant, you cannot break this bond. And so you can't break it down, and it causes all kinds of crazy digestive issues, which I won't go into. All right, the third group of carbs, polysaccharides. So you're still filling out your table. We've got two types, and there's two functions. Energy storage ones, that's a little bit more longer term energy storage and structure. So we have many monomers hooked together. They're not as soluble in water. Why? Because this is we're going to store our energy. We want it stored and not breaking down before we need it. And because we need it to be strong if it's structural. So, filling out your table, plants store energy as starch. You're very familiar with that. Potatoes, corn, rice, all have lots of starch in it. And that's not for us, but it's for those organisms to have ready energy in the spring. We just tap into it. So starch molecules look like this. They're really long chains of glucose monomers. And here's a little teeny bit of one. You'll see it goes on and on. Then we have something called cellulose. We're talking structure now. And those monomers are bound by a bond that animals can't break. So if we can't break it down, why do we still eat it? It's called cellulose, and so celery, if you want to think of celery, it's mostly made of cellulose. Those long, stringy things in there are made of cellulose. We eat it because it's fiber and it's great for our digestive systems. It's the most abundant carbohydrate on Earth, and it's the most abundant organic molecule on Earth. 100 billion tons are produced each year. Whoa! If we can't break it down, why aren't we buried in it? Well, it turns out bacteria in the guts of certain animals, including termites, break it down for us. So that's how a whole ruminant works. They have several stomachs, which you've heard about. Well, there was one pouch with the bacteria in it that breaks those bonds for them. So it kind of goes through there. So they depend entirely on those bacteria to break cellulose so they can get energy. Special little trick of rabbits. They poo and then eat it again and then poo it out. So through that process, bacteria is introduced. Very disgusting. Poor rabbits. Okay, so animals, we have energy storage as glycogen in our livers. The storage and release is controlled by insulin, which you're familiar with. I won't tell the whole ski story, but it didn't go well for me. And so animals, structural, is chitin. That's in the exoskeleton of crabs, shrimps, and so like if you love shrimp and you peel the shell off, that shell is chitin. And we have discovered it has natural antibacterial and antiviral properties. So we're starting to use it in medicine. Pretty darn cool. And that's just a quick review. Which one is used by animals for energy storage? Which is used by plants? Purpose, energy, that's what I'm telling you. Fill that table out, you're ready to roll on this. All right. Lipids, let's begin. Fats. These aren't really a polymer, by the way, because they're made of different things. I think there's a question like that in the test. So they're insoluble in water due to hydrocarbons. Oil and water don't mix. That's what we're talking about. So hydrogens bonded only to carbon will not form hydrogen bonds. So you see that they have these long chains of carbon and hydrogen hooked onto a glycerol. So they're diverse, like I said, so they're not really polymers. Trick question, huh? All right, so we have the glycerol, and 3 fatty acids are hooked up in, oh, look, dehydration. And we have 2 different types, saturated and unsaturated. This guy up here is saturated, as is this. Unsaturated is here. And it turns out that if there is an unsaturated one, that means that there's not a hydrogen on every bond and a couple of carbons have a double bond on it. It kinks. That lets it be liquid at room temperature, which is, I think, pretty awesome. So we're talking plants, olive oil over here, saturated, packed tightly, solid at room temperature, animal fats. These guys are full of hydrogen, solid at room temperature, generally from animals, not full